Chapter 4 of a Navigation API. In my last series of articles, we followed the history of client-side routing all the way from Flash plugins to the modern day with the History API, which was standardized with HTML5 in 2008. The History API has fueled single-page applications for the past 15 years, but there's still a few rough edges. Late last year, the Navigation API was added to the HTML spec to help solve these problems. Before we take a closer look at this API, let's look at how our router works right now for comparison. Alright folks, we are here inside of our demo application where we have our routes.js, which has our central routes configuration, which we use our route function here to look inside of and then dynamically import the component that we need inside of our router, which first looks to see if it is a dynamic route. We only have one dynamic route right now, which is product. If you looked in the last video, you actually got a sneak peek of how we make this more generic in the future. And then over here we have the search route, which we actually have two ways of searching in our application right now. You can either, in products, we look to see if there is a search parameter called a name, but then we also are searching on every single route. When we load the application, we're actually checking to see if the search parameter is there. So I just wanted to show two different ways to do that. I know it's redundant. And then we just checked for all of our other routes here at the bottom. Pay attention to this event listener. This is necessary with the History API. The browser has no way of knowing when you hit the back or forward buttons unless you put down this event listener. So that is very important. Then we also have our other event listener, which we put down on every single link. The History API doesn't know which anchor tags you want to be internal links unless you go through and prevent the default behavior on each one, and then you do this push state with the History API right here, which we aren't using these first two items here. The first item is state. We'll talk more about that in a moment. The second item is title, and that's actually completely deprecated now. Nobody uses this anymore. Browsers don't even respect it. And then lastly, we have the actual path that we want to push into the URL, into the address bar, and then we run our router with that. And so we have to place this down on every single internal anchor tag where we want to use our client-side router. And then on another basis, we also have our checkout here. We have to prevent the default behavior here, so that doesn't work unless we have JavaScript enabled like the rest of our app. But still, I'm going to put out how we use the post redirect to get here. We'll talk more about that in a moment. But this is the beginning of our application working along with our server. Before we were just doing this one splat route, but now we're doing a little bit of a post route here. Nothing too exciting, but it is the beginning of us exploring the balance of client and server. And then we have this success route over here, which we redirect to. We'll talk more about this in a little bit, but it's just listing off the things that the person has purchased. And then that is our client-side router using the History API. Let's take a look at how the Navigation API works so we can see how it will improve upon this, and then we'll use it in our application.
All right, let's take a look at the code here for our first demo. As usual, the markup's going to be extremely simple. We're just going to have a main area and a couple p tags, one of which has the ID of count. And as the script starts, we're just going to grab that main area and that count p tag. And as soon as the script runs, we're going to log to the console something called navigation.currententry. So the Navigation API, like all the other web APIs, just sits on the window object. So this is actually saying window.navigation. If you run something in the browser and you know it's not going to run on a server or anything, you can just type navigation and the browser will interpret it as window.navigation, and then we're going to log the current entry, and that's just information about the current page that loads as soon as the browser will load this page. And then anytime that a user clicks on a link, we're going to log that navigation event. So first off, we log the event, but then we also log navigation.entries, which is a function that gives you an array of all of the pages that are on that session's history. So then we run the event.intercept function. And so the way that this method works is it's going to actually intercept all navigations. And so the function takes an object with a handler property, and this is going to be your key. This is going to be where you put all of your custom routing logic. So here we're just going to make a new URL object with the URL, which we get from the event object, It has a destination property, and on that is a URL property, which has information about the destination's URL, obviously. And so then we're going to run this router function, which we'll look at in a second, with the path name from that URL. And we're going to update the count with however many entries are on the navigation history stack. And then down here is our router function. Very simple. If we're going to any path name called special, then we make the page special. Otherwise, the page is boring. And as we load up the location.path name, it will not be special. So we take a look here. The page is boring, and we have logged the current entry to the console. And here, it's just it's just a way of identifying what's going on with this page compared to other pages. And it gets two UUIDs, the key and the ID. The key is a little bit more stable than the ID, so I feel like it's a little bit better to rely on the key between the two. And so here we click on Make It Special, and we have this navigate event with the destination URL, which we are using in our router. And there's a lot of really important events here, a lot of good information here, such as the form data, which we're going to be using in our forum later. But you can also see if it's a download request, or you can see if event prevent default was run on it, or if it's even can be intercepted, because external links like this one can not be intercepted. So as you can see, we only need to place one event listener, and the router will intercept all of our anchor tags, which we don't have to put any special class on, and respect the backwards and forwards buttons. So boom, backwards and forwards. We didn't have to place a special popstate listener to deal with the backwards and forwards. And you can see that we are counting the entries, and we have access to every single entry in the list on which we can actually traverse the list. So with the history API, you actually didn't have any access to this list whatsoever. And we'll talk more about this in a second. First, let's take a look at the event.intercept method and see how it differs from preventing the default behavior of the browser. If you'll remember, in our history API router, we were preventing the default behavior of the browser quite a bit in our checkout and in our link component, and so we had to do it all over the place. So I made this other demo to help us understand the differences here. And so one of the main things that are really different here is something like a form. So I have two forms here, one that does a GET request and one that does a POST request. And then this button here will change the mode between preventing the default behavior of the browser, doing the normal behavior of the browser, and then doing the intercept method. And then down here we're logging the URL because that's one of the main things that changes. And then there's a lot of logic here, but the important thing to understand is that we're going to be going in between the different modes to understand what's going to happen. Let's start with the default behavior of the browser. So we have a couple of forms here. And so generally when you submit a form, it's going to do a GET requests with a couple of parameters. Whatever inputs you have here, whatever name you put, the value will be put into a parameter with that name. And then if you don't put an action, it will be on that same URL. If you put an action, you can define the URL to which you will do this request. A POST request is very similar, except it doesn't use parameters. Instead, it uses a request body. So we'll see how this works. If we do a GET requests, we're going to do it to that URL and it will append the parameters. However, if we do the POST request, it will send us to that URL with the request body, which if we do something like refreshing, actually sends that request body again, which can be an issue. I have this other demo where we can create a user and then do an order, and we now have 3 users and 8 orders. Let's go elsewhere. Wait, what did that say? Let's refresh. Oh, wait, 9 orders? 10 orders? What's going on here? So you can see that if you allow the user to do post requests willy-nilly, it can actually lead to some unwanted results. So instead, people do something like a post redirect get, where you will, instead of actually going through and doing the whole thing, you'll stop, fetch the result from the server, and then you actually redirect and do a get request of a different URL. This is how we're doing it on the old router. But on the new router, what we can do is actually something a little bit different, where we just intercept it, and then after we intercept it, we can do something similar But when we can just navigate over there and replace it in the history, it's all very, very nice because this can actually still do the normal requests, which will go through to the URLs. But so you don't have to do it like this with prevent default, where it never changes the URL. You can do some internal links, but it's not going to let you leave, and it's just not the behavior you want. And when you have the intercept on, you can actually do some progressive enhancement because you can actually still make these requests to the server. And even if JavaScript doesn't work, this will still actually work because it's still a normal form, the way that the internet was made to work. It's web standards. But you can also have your internal routing logic, but your external routes still work. Your external links still work. So this is just one of the many ways that Navigation API is better, because you have access to this event intercept method. Let's take a look at some more ways that the Navigation API really makes our lives easy. Our next demo here is going to be about state objects. And so you might remember with this link component, when we were using the push state method here, the first argument was a state argument. We could put an object in here to save state in between routes. And you might have wondered why we weren't using it. It sounds pretty handy, right? Well, I mean, yes, it can be. You can store some stuff in here, like at what page if you're using pagination on the client side. But I mean, it's a little bit fickle and it's not that handy in the end because it can be very out of context from where you were before. Sure, you can go back to your favorite state, but wait, what about those websites we went to afterwards? And another thing that we can do is like, what if we hit a hash link? Oh, we just lost the state. And we can go back there, but it's out of context from the ones that came before and afterwards. And so look here, when we turn on the navigation API mode, we can actually go back and forwards to every single state that we have been to before. And it's going to be fully in the context of the ones that came before it and after it. So it's a lot more reliable too, because we're hitting hash links. Well, that's just a new entry in the history, and we can go backwards and forwards to those too. It's a lot more reliable, and so this makes it so you actually kind of want to use the state object. It's not going to go away at a moment's notice if you do the wrong thing. And with all of these entries here that we can log, it's super handy going backwards and forwards. You can save the state and know you can go back to it at any time. Additionally, the Navigation API allows us to have multiple navigation contexts within a single page. So if you'll see here on this bottom iframe, if I click on that button down there, and then we go up here and we click on this back button, which is tied into the browser's back button, it's going to take everything back on the entire page. But if we change over into navigation mode, you'll see that if we try to go back, they're each specific. So there's only one entry on each stack. It can't go back because each stack is independent of one another. We had this history stack, but all we could do is just kind of see how many items are on it. It doesn't really even show us what's inside of it. However, with the navigation stack, we can go to each entry and they will take us backwards and forwards in time to that specific context of that specific stack. This is something that was completely impossible with the history API. So I set up an artificial delay here in our database function to simulate some network latency to show that if we are waiting on something that relies on something that's a slow network call, we're not going to get any indication of it in the browser. Even if it eventually works, it doesn't really seem like it's working because we don't have a loader up here. We can't click stop up here. So, I mean, I guess that's everything that happened. But then, I guess it'll work. So going into our next demo here, we can see how the Navigation API improves on that. So with the Navigation API, we actually get access to all of these browser indications of loading, and we can even have special responses to if a user hits the stop button. We can actually say something special right here. I'm just putting up the error message, but you can put anything right here if you're responding to the navigate error event or to this abort signal, which gives you this on abort event that you can respond to. And so you can have those, but you can also have special loading screens for each route or special error messages for each route. The Navigation API gives you so much flexibility. And you can see here, I just define a quick CSS and we just have a couple buttons. We have a button and a link. And when we look down here, we have the committed and finished promises. I'm using the explicit navigate function, which is available in the navigation interface. And so with this, we can await the committed. We know that we are beginning to load the navigation. And here we can put a loading screen with a dark spinner. And then we can also respond to each navigation event. So like that anchor tag that we can have and on this we can listen for the abort signal. The navigation API gives us an abort signal with every single navigation. And that's what we're using to have those special stop messages in here, which are very, very useful, because in the history API you had absolutely no way of knowing when the user might not get the fully loaded page. You couldn't give them any kind of message and they might just think your website was broken. So to wrap things up, we have our website here, which now has a very exciting spinner. And that is the main difference that you can tell from the front end. But in the back end, everything's a lot nicer, a lot cleaner. We can check to see if it's a dynamic route in the routes array, and then that changes our route function. Inside the router, we just check to see if we even should run it, and then we check to see which URL it should be. If it's the first load, we just get it from the address bar. If it's not, if we have a navigation event, then we take it from the destination URL. Scroll to the top if it's the same page. Do a search if there's any search parameters. We just set up a spinner after 300 milliseconds if the page has not changed. Otherwise, we are awaiting the router to work up here. If it's the very first load, then we run the route down here, and we just set up the event listener here, and we are done. It's really just that simple to make a router with the navigation API. It's really, really fantastic. I recommend it to anyone and everyone. There's not a lot of examples out there, so hopefully this extremely thorough video has helped you, and we'll see you in the next chapter of View Transitions, another really incredible API. I cannot wait to share this with you guys.